will work on Leetcode 3193, count the number of inversions. This is a Leetcode hard problem, and let's first see what this question is about. So we're given an integer n and a 2D array requirements. And where requirements has two numbers, and it is guaranteed it only has two numbers. The first number is an and I. It's the position. It's an index. And the second number is a count I. It's a positive number. And this is represents the end index and the inversion count of each requirement. So, and there is a definition of reinversion here. I think if you have done some questions before, you would already quite familiar with this, what is inversion. So it means if some two numbers, the index is the first number less than second number. However, the value of the first number is greater than the second, then we call this an inversion. And we are required that we need to return the number of permutations of the number from 0 to n minus 1. There are total n numbers, so that all the requirements are satisfied. So which means for each requirement, at requirement I, the end index, it should have a total of count inversions. So the number is quite large, so it do some modulo operation. Let's see some examples so to make it more clear. For example, if n equals 3 and the requirements are these two, and for number 3, the kind of permutation are a lot. However, only two permutations will satisfy both. So one of the permutation is 201 and the other is 120. And you can see that for this requirement, it requires us from 0 to 2. The index is 2, is 2. So it's all these three numbers. And it has inversion count only 2. So because this one is larger than this one and larger than this one, so there are two inversions, as shown here, right? And for the second 0, 0, because at 0 index, it always has 0 inversion, so it's already satisfied. And similarly, you can see the second permutation is also satisfy this requirement. And if you list all the other permutations, you will notice no other permutation will satisfy. So the output is just these two cases. We output 2. And this is a quite hard problem, and I think the constraints can provide some hint, because it's really, we don't know how to do it. But if we look at the constraints, the number of n is 300, and the number of count is 400. At this level, for sure we cannot do the exhaustive search, right, for all the permutations. And it seems this number fits for the range of dynamic programming algorithms. So one key observation is we need to somewhat calculate the dynamic programming of some state, and we define the state Fij to be the first I element, which is from 0 to I minus 1, right? The count of J inversions. Okay, so the I means the number of elements, and J means the number of inversion. So we need to calculate Fij to help us to calculate this number of inversions fits the requirement. So how to calculate Fij? So we for example, if we have this number from 0 to 4, let's say 3, 1, 2, 2, 0, and 4, okay? And now we are going to add 5 into into this array. So how many additional inversions can we get? So one of the choices, if we put f here at the position 3 does, and we move all the elements to back on the right, so we will have 1, 2, 3, 4, 5. Okay, we will have 5. We will have 5 inversions. So the first choice is to put 5 here. So we will have 5 inversions, right? How about the second choice? The second choice is put 5 somewhere here, right? To use 5 to put at the position where 1 was, and put all the elements on the right, because we're adding 5. 5 is greater than any of those numbers, so that for this case we are adding 4 more elements. So which means if we put 5 at position we say k, then how many we can have? So for example, we put it at position 0, we have 5 minus 0, right? So we at position k, we will have 5 minus k, more elements, more inversions. Then we can have our DP algorithm. The DP conversion is Fij is the max of Fij. Oh, it's actually Fij plus I minus 1 and j minus I minus k, right? And for k equals 0, 1, 2, 3, all the way until I. Right? So all the way until I. So we have 5 elements here. And actually for I, it's 5 minus 5. So we can actually just calculate until I minus 1. Okay. Then after we have this number, we can use the condition for requirements, because at some j, if the number is equal to what we see in the requirements, we can still use them. But if the number is not inside the requirement, we will drop it. Okay, so let's maybe it'll be more clear if we see the code. So let's write the code first. We have n, and we don't need to redefine. However, we have the number of count is 400, so we have dp like 305 or 405, so that we don't need to worry about the boundary conditions. So the mem set and f0 size f. Okay. We set all the member value in f to 0. Then we do the loop. and we believe F00 means the first 0 element with 0 inversion. This is 1. First 0 elements, 0 inversion. Equals 1. Okay. Then we can loop from I equals 1 all the way into I equals n, because we have n elements. And we will loop j equals 0. J will be less or equal to, I think the maximum of count is 400, so j can be less than 400 plus j. Okay, then we will loop k. K, the value is k equals 0, k less than I plus k. If j minus I minus k is greater than 0, greater or equal to 0, we can update Fij. Fij plus Fi minus 1 j minus I minus k. Okay, and this we need modulo by m. 1 plus 7, if I remember. Okay, yeah, it's 1 plus 7. After this, we will have the correct Fij. Then we will remove all the invalid Fij. How to do that? We use another variable and state called requirement. Requirement, is there any limit on the number of requirements? The requirement length is less than n, so it's 305. And we initialize all the item in requirement to -1. Or you can use minus infinity. It doesn't matter. Then we loop over all the requirements. So we let R0 plus 1 because we are now indexed from 1 here, and the requirements are indexed from 0. So this will equal to R1. So after this, REQI means the number of inversion requirement at first I elements. Okay, then we can actually calculate this. So I equals 0, I less or equal to 300, and if QI is not -1 and REQI not equal to, this should be all, right? There are two cases, either equal -1 or it's with some value. However, it doesn't equal to j here. Then Fij will be reset to 0. So in this case, we remove all the invalid Fij. Because if for some Fij, and for the specific j is the number of inversion, right? And for this I, the required inversion does not match our requirement, then Fij is just 0. We have 0 number counts. And I think that's it. Finally, we just return Fn and the final requirement, n minus 1. It should be required n, I think. Let's see. This is also. And let's see here. J is not defined. I think we need to loop over J, right? This should be J, right? Fij. We are at some specific I, and we check for all the J. And for J, it should be 400, right? And this is also 400. Oh, this should be 300, right? And runtime error. Let's see. Requirement I, and let's see, Fij, J is 400, I is 300, requirement is 300. This is guaranteed, and it says index 305 is outer bound. So here n is only 3, so required I is only 3 here. This is only 3, and REQ is only 3 as well. Let's first delete this part, and let's see. Okay, so oh yeah, this should plus plus J, right? This is not plus plus I. And we have some result. Let's see what's happening. The output is 0, and we expect it to be 2. All the requirements are not satisfied. So let's see. So let's read the program again. So we have a f, and we have mem set it to 0. This seems correct. And then we have a requirement. We initialize the size to 305, and we put initially put -1 to all its values, right? And for each requirement, we update requirement. Okay, this also seems correct. So how about this update? I think if there's something wrong with the update, then it might have some issue. So I don't think we need this equal here. And so this is ij, right? And I minus 1, j minus okay. We need, how about the initial condition? Initially, this is 1. Okay. I think for symmetry, we don't need I minus k. We just need k here for simplicity. Okay, I don't think this will matter, but this is simpler. We have this f is preset to 0 for all the positions, and requirement is 305, and we have set all the requirement to -1. Let's set all item to -1. And for each requirement, requirements R0 plus 1 equals R1. Yes. And we will do the for loop. I think this is and, right? It's not equal to -1, and not equal to j. Okay, so if it can, it's -1, then it doesn't matter. Yeah, so you cannot, you should be, you can be either -1, but if you are not equal to -1, then requirement should not equal to j. This is just if not req equals -1 or req equals j. This might be easier to understand. This means you either is -1, which means we don't have any requirement, or the requirement equals to j. Yeah. Let's submit. Okay, it worked. This is a quite complex problem, I think. It's hard to think of this part. I think after some working, you will be able to get this part. But for this part, it's a little bit difficult to understand and come up with. So that's it for this problem, and see you next time. Thank you.